Okay, so in today's lecture, we are going to learn about types of precipitation. Yesterday, we have discussed how precipitation occurs, and now you know that the precipitation takes place due to various meteorological factors. Due to solar radiations, evaporation takes place, and due to evaporation, water from various surfaces that is converted into the gaseous state, which is available in liquid or solid state, that is converted into gaseous state, and then it is known as a water vapor, and these water vapors are absorbed by the air masses. Previously, air masses are almost dry, and during this evaporation process, these air masses absorbs the moisture, and this process is continued till these air masses get saturated. Meanwhile, the wind is blowing over these water surfaces and land surfaces, and this blowing wind over the land surface and water surface removes that air masses above the water bodies. So they shifted these moisture laden air masses to the other area, and by wind action, these moisture laden air masses, they are lifted up, they are lifted at higher altitude, and at higher altitude there is a low temperature, and due to that, at that place condensation takes place, and then the fall of moisture from atmosphere takes place. Okay, so this is how the precipitation takes place. So here we came to know that the wind plays important role in precipitation. Okay, so based on the role of wind in lifting the air masses at higher altitude, this is the classification, or these are the types of precipitation. So one is thermal or convective precipitation. Second is known as a frontal precipitation. Third is known as orographic precipitation, and fourth is known as cyclonic precipitation. Now we will discuss all these one by one. So first one is thermal or convective precipitation. So in this type of precipitation, what happens? Due to solar radiations, Earth's surface gets heated. Okay, due to solar radiation, Earth's surface gets heated, and due to that, what happens? The evaporation takes place. Okay, and along with that, the Earth's surface gets heated and it becomes warm, and the air mass which is close to the Earth's surface, that also gets heated, and these warm air masses, they are goes up by natural process. Okay, their density is reduced, that's why they go up by natural process, and they reaches at higher altitude. In this way, the moisture laden air masses reaches at higher altitude, and in that case, the clouds forms are of cauliflower shaped clouds. Okay, cauliflower shaped clouds are formed, and then they burst into a thunderstorm. Okay, heavy rainfall takes place in case of thermal or convective precipitation. So this type of precipitation is generally observed near to the equator. Okay, near to the equator, the sun rays are nearly vertical, and that's why our surface gets heated. So from the morning to the afternoon, this heating of our surface takes place, and in the evening, then a thunderstorm takes place. Now sometimes when these thunderstorms accompanies with the destructive wind, then this is recognized as a tornado. Okay, so this is about thermal or convective precipitation, and see, this is a sketch of conventional precipitation or thermal precipitation. So nowadays we are experiencing the same type of precipitation. Okay, it is said that in October month there is a lot of heat. Okay, a lot of heat is generated in this month, and from the afternoon clouds are formed and heavy sessions of rainfalls takes place everywhere. So this is example of convectional precipitation or thermal precipitation. The second type of precipitation is frontal precipitation. So in this frontal precipitation, term front is used. Okay, so what is this front? Front is the surface of contact between two air masses of different densities. Okay, now it is clear to you how the precipitation takes place. For that, the air masses are laden with the moisture, and some air masses get saturated, some are partially filled. So there is a difference in the densities of two air masses. So surface of contact between the two air masses of different densities is called as a front. Now in frontal precipitation, again there are two types. First is cold frontal precipitation and second is warm frontal precipitation. Now what is cold frontal precipitation? In cold frontal precipitation, the cold air masses drives out warm air masses. Okay, and due to that the precipitation takes place. And see how precipitation takes place. Intense precipitation takes place on a smaller area when cold air masses drives out warm air masses. Okay, and in that case that front is known as cold front. Whereas when warm air masses drives out cold air masses, then it is known as warm front. And when there is a warm front, then it results precipitation of less intensity and comparatively on larger area. In case of cold front, intense precipitation takes place, intensity of precipitation is more and area covered is small. Okay, more intensity and on less area. And in case of warm front, less intensity on larger area. So this is cold and warm front. Now when the warm and cold air masses, if they are flowing towards one point, now generally how wind flows? Wind flows from high pressure to low pressure. Okay, so if the warm air masses and cold air masses, if they are drawn towards the low pressure belt, in that case the precipitation occurs is known is in that case that front is known as a stationary front. Okay, when these two air masses meet at a low pressure belt, it is known as a stationary front. And when there is a stationary front, the precipitation is intense and precipitation takes place on a comparatively smaller area. Is it clear to all? What is frontal precipitation? What is front? It is clear to you. What is cold front? When cold air masses drives out warm air masses. What is warm front? When warm air masses drives out cold air masses. Okay, and when warm and cold air masses drawn towards the low pressure belt, then that front, that contact surface is known as a stationary front, and in that case very intense precipitation takes place on a comparatively smaller area. So again it is request to all, you have to join in time because every time I have to stop and I have to add the students. Is it clear? Okay. So these are the sketches of cold front, warm front, stationary front. Cold air masses and warm air masses when they are drawn towards one point or towards the low pressure belt, then the contact surface is known as a stationary front in which intense precipitation takes place. The next type of precipitation is orographic precipitation. So as we can see in the figure, so what is orographic precipitation? So when the air masses are lifted due to some natural barrier, okay, or due to any barrier like mountain. So in that case, when precipitation takes place, it is known as a orographic precipitation. Okay, so the first one we have discussed, convective precipitation. So in that case, or thermal precipitation, in that case, air masses gets lifted as they becomes warm, and as air becomes warm, it becomes light. We know that. So this is the way to lift the air masses. In the second case, one air masses drives out the other air masses. Okay, warm removes the cold, or cold removes the warm air masses. So this is the way to lift these air masses at higher altitudes. And now in this case, these moisture laden air masses, they are lifted up at higher altitude due to some natural barrier. Okay, it's like mountains. So in our western Ghat area, the precipitation takes place is of orographic type, because from Arabian Sea, when monsoon wind reaches to the Indian continent, so there is a large barrier of Sahyadrian mountains. And due to this barrier, these clouds get lifted at higher altitude. And due to that, the heavy precipitation takes place on windward side. So in case of Sahyadrin mountains towards western side, that is in Konkan region, there is a very intense rainfall. And there is a less rainfall in leeward side, that is on opposite side. So as we go towards the east side, this rainfall intensity goes on reducing. So when air masses gets lifted due to the barrier like mountain, then it is orographic precipitation. And orographic precipitation results in intensive precipitation, heavy precipitation. Okay, yesterday we have discussed what is meaning of intensity of rainfall. Okay, if intensity of rainfall is less than 1 mm per hour, then it is known as a very light rain. Okay, and this intensity may be 5 centimeter per hour to 10 centimeter per hour in some cases. So that is intense rainfall, where intensity is more. So in this case, such a intense or heavy precipitation takes place on windward side. Okay, so this is orographic precipitation. The next type of precipitation is cyclonic precipitation. Now, we know that in the newspaper, often we read that some cyclone is coming, or some cyclone is developed in Arabian Sea, or it is developed in Bay of Bengal. Okay, and due to that, there is a possibility of rainfall in several districts of Maharashtra or in various states of the country. So precipitation also takes place due to cyclone. Now, what happens in case of cyclone, or how precipitation takes place due to cyclone? Due to cyclonic action, what happens? The air mass gets lifted. Okay, and why these cyclones are developed? Cyclones are developed due to the low pressure belt. Low pressure belt is created, and when this low pressure is concentrated at a point, then from all direction wind starts flowing towards that low pressure point, and due to that the cyclone is formed, and this cyclone results in lifting of air masses, and due to that precipitation takes place. It is known as a cyclonic precipitation. Now, cyclones are broadly classified into two types: tropical cyclones, which are known as a hurricane or typhoon, in that case, the diameter of cyclone varies from 300 to 1500 kilometer, and wind velocity is very high in that case, and it results in heavy precipitation. Second type of cyclone is recognized as extreme tropical cyclone, whose diameter is up to 300 kilometers, and it results in the high wind velocity in the area, and it results in also heavy precipitation. Okay, there is a term tropical cyclone. So what do you mean by tropical term? Tropical, it is said that India is a tropical country. Okay, so there is a belt of tropic, and the countries which are in the belt of tropics is known as a tropical country. So India is a tropical country, and that's why the cyclones produced in this tropical zone, that is known as a tropical cyclone. And in tropical zone only this monsoon rainfall occurs, not everywhere on the surface of earth. So this is about cyclonic precipitation. We will discuss these topics in detail in the next part. Okay, so these are some sketches of cyclonic precipitation. The first figure shows the low pressure area, and from all directions the wind is approaching with high velocity, and due to that whirling action is formed and cyclone is formed, and this cyclone lifts up the air masses at higher altitude. And next two figures are the satellite imageries, which shows the position of cyclone. Okay, after studying all these types of precipitation, now let us know about the factors affecting hydrological cycle. So first factor is the topography. Now, thank you, sir. Okay, the first factor affecting hydrological cycle is topography. Now, to affect hydrological cycle means what? To affect three phases of hydrological cycle. So, which is the first phase? Evaporation. Okay. Second is which are important phases of hydrological cycle? First is evaporation. Second is, please reply. Huh? बरोबर आहे?
Precipitation.
Precipitation. थोडंसं मोठ्याने बोला. Precipitation. And third is
Runoff.
Runoff. Good. So now we have studied some points. Based on that, now tell me how topography affects these three phases. Whether topography affects the evaporation process, whether topography affects the precipitation. What do you understood from the term topography? So topography includes the physical characteristics of the area. What is the slope of the area? What is the shape of the area? Area means that catchment area. Okay. So what is the slope or how is the terrain, whether it is a hilly terrain or it is a plain terrain. Okay, so all these things are included in topography. So now tell me how topography affects the phase precipitation. What you will say? Just now we have discussed in previous point types of precipitation. How topography affects precipitation and runoff. कोण सांगेल का? Yes. बोला. So what we learn now in case of orographic precipitation, what we learn?
Sir, high hill area जर असेल तर तिथे रेनफॉल जास्ती होणार.
Correct. Correct. So if topography consists of hilly area, in that case, rainfall is more. If topography consists of the plain region, rainfall is less. That is correct. Again, the location is important, where that catchment area is. So if the catchment area is on equator, in that case, what will be its effect on precipitation? Precipitation will be more. Okay, on equator, the sun rays reaches nearly vertical to the Earth's surface, and due to that, convective precipitation takes place, and always there is a rainfall. In almost every evening, there is a rainfall. So this is how topography affects the amount of precipitation, intensity of precipitation. Topography also affects the runoff. What is runoff? That is known to you. The water or part of rainfall water which ultimately reaches to the natural tributaries or rivers, that is a runoff. So if there is a hilly terrain, in that case slopes are steep, and due to steep slope what happens, that water immediately moves from that place. So there is a very less chance for percolation, infiltration, and then for percolation. So if terrain is hilly, in that case runoff is more. If terrain is a plain, standing time for this rainwater. And due to that what happens, there is a sufficient time for infiltration and percolation. So that's why in case of hilly area, runoff will be more. In case of plain terrain, runoff will be less. This is how topography affects the hydrological cycle. Second is geology. Now what do you mean by geology? Geology is a subject which deals with the study of the earth crust. Okay. So when the precipitation takes place, and if the geology of the basin is such that there is a more chance for percolation of water, in that case that basin yields less runoff. And if the geology is such that there is a impervious barrier of rocks in the upper layers, in that case runoff will be more. In first case, groundwater will be more and runoff, surface runoff will be less. In the second case, surface runoff will be more and groundwater level will be less. So this is how geology affects the hydrological cycle. Then climatic factors, humidity, temperature, solar radiation, wind velocity. Just now we have discussed what is the role of wind in precipitation. Okay. Then what is the role of solar radiation? Due to solar radiation, evaporation process takes place. Just a minute. Okay. So again, there is a role of temperature as well as the humidity. So what do you mean by humidity? Humidity is the percentage of moisture contained in a air mass. If we consider air mass, then that air mass is having some saturating capacity. We know that during evaporation process, that air mass absorbs moisture and later on it reaches to some saturation capacity. After that, further evaporation is not possible. Further absorption is not possible. So in that case, the rate of evaporation will be reduced. That is the effect of humidity on evaporation process. If humidity is more, in that case, there is a favorable condition for rainfall. Okay, so this is how all these climatic factors affect the hydrological cycle. Okay, now we are going to discuss one of the interesting point of this chapter, that is Indian monsoon. Okay, so we know that in India the precipitation takes place due to monsoon. Okay, so do you know what is the meaning of term monsoon? Yes, anyone? Monsoon. Do you know about anything related to monsoon? What is monsoon?
Rainy season.
Rainy season. Okay. Any other? This term monsoon is derived from the Urdu word mausam. Okay. So mausam means it is a season. So monsoon is a season in which the rainfall occurs in India. Now, in India, now related to this Indian monsoon, we are going to discuss following points. What is the role of ITCZ, that is Intertropical Convergence Zone? Then the Indian monsoon is divided into two types. One is southwest monsoon, that is also known as onset monsoon, and the northwest monsoon, that is known as the retreating monsoon. Okay, so let us start with the definition of the term monsoon. So what is monsoon? A seasonal prevailing wind in the region of South and Southeast Asia, blowing from the southwest between May and September and bringing the rain. So that is known as a wet monsoon. Or from northeast between October and April, that is known as a dry monsoon. So it is said that the monsoon reaches on the Indian coastal area on some specific date. So do you know that date when monsoon reaches to the India?
June to September.
June to September. सर तुमचा म्यूट आहे माईक.
ओके ओके. याच्या वेळी चालू होतं का हे बोल? समोरची स्लाइड. या स्लाइड वेळी सुरू होता का माईक? हॅलो, कॅन यू हिअर मी?
हाँ सर, होता होता.
हाँ.
Yes, sir.
Okay, so in India, this monsoon reaches around 1st of June in Andaman and Nicobar, and later on 7th of June, it reaches to the coastal region of Kerala. Is it clear? So these are the dates of monsoon. Now let us know about the intertropical convergence zone, ITCZ, and this ITCZ plays an important role in this monsoon. So this is the earth, we can see. Okay, there is an equator, there is a tropic of Cancer at a angle of 23.5 degree towards north, and there is a tropic of Capricorn. Okay, so you can see a tropic of Cancer and tropic of Capricorn towards south. So consider the area between tropic of Cancer and tropic of Capricorn. So this area is known as a tropical belt. Is it clear? This is known as a tropical belt, and India, a part of India or majority of India lies in a tropical belt, tropical country, tropical region. And in tropical region, generally the monsoon precipitation takes place due to monsoon. Now this is the equator. I have mentioned about equator, that on equator convective precipitation takes place. Now what happens from northeast side? The trade winds are flowing. Okay, in this direction the wind is flowing in northern hemisphere, and in southern hemisphere from southeast side this wind is flowing, and the convergence is taken place near to the equator, and on the equator the low pressure belt is created. Okay, now let us know about the definition of intertropical convergence zone, that is ITCZ. So ITCZ is a belt of low pressure which circles the earth generally near the equator, where trade winds of the northern and southern hemisphere come together. Okay, what is ITCZ? It is a low pressure belt which circles the earth along the equator. Okay, it is almost parallel to the equator and it encircles the earth. And how this low pressure belt is developed? It is due to the flow of trade winds from the northern hemisphere and southern hemisphere towards the equator. Okay, so this is ITCZ. Now what is trade wind? Trade wind is a wind blowing steadily towards the equator from the northeast direction in the northern hemisphere and southeast direction in southern hemisphere, especially at the sea. So two belts of trade winds encircles the earth, blowing from the tropical high pressure belts to the low pressure zone at the equator. So what is trade wind? Trade wind is a wind which flows from northeast direction towards the equator. And here in southern hemisphere, from southeast direction towards the equator. And on the equator, the convergence takes place. And this intertropical convergence zone is developed. Okay. So in this figure, we can see this ITCZ, which is almost parallel to the equator. Okay. So now it is clear to you what is ITCZ and what is trade wind. Now we will come to the point, that is how Indian monsoon takes place. So in case of summer season, so before the starting of the monsoon, before that for 4 months, what happens? Excessive heating takes place in Indian continent. Okay, on the Indian continent, excessive heating takes place. And due to that, the low pressure zone is created. Okay, as a low pressure zone is created over the Indian continent, this ITCZ gets shifted towards the Indian continent. It gets shifted towards the Tropic of Cancer. So this is the sketch. This is the enlarged sketch which shows the shifting of ITCZ. See, where was the ITCZ initially? It is along the equator. Okay, it is along the equator. And in summer season, due to excessive heating, this gets shifted towards Indian continent, where the low pressure is developed. So this is shifted towards Indian continent, and that is shown in the next figure. And as low pressure belt ITCZ is shifted in Indian continent, so again wind starts flowing from the ocean towards the Indian continent. And this wind which flows towards Indian continent in this process, so that is known as the monsoon wind. Okay, आपण मराठीमध्ये त्याला काय म्हणतो? मौसमी वारे. So this monsoon wind reaches to the Indian continent. And during this heating process of Indian continent, also a lot of evaporation takes place over the ocean, and all the air masses are fully saturated. And during the journey of this wind also brings with them this moisture laden saturated air masses with them. And this air mass reaches to the continent. So when it reaches to the Indian continent, what happens? It reaches to the western coast of the India. So when it reaches to the western coast of the India, then there is a barrier of Sahyadrian mountains. Okay, so due to that, at this point, it is at first divided into two branches. So one branch will go parallel to the Sahyadrian mountains. Okay, and other branch will go parallel to the eastern course. Okay, and this journey of Indian monsoon wind, this journey continues for next 4 months. Okay, June, July, August, September. And due to these winds, precipitation takes place, and this precipitation is called as a monsoon. Okay, it is a Indian monsoon. It is a onset Indian monsoon. It is a southeast monsoon. Now it reaches to the coastal area on 1st of June. Okay, and when it goes towards the heart of the country or towards the Delhi, so this monsoon wind reaches to the Delhi around 25th of July, and this journey continues till the Himalayan ranges. Now again there is a obstruction, and lot of time is required to reach this monsoon wind from this Sahyadrian ranges to the Himalayan ranges. Almost 4 months are required. Now during these 4 months, what happens? This Indian continent becomes cold. Okay, and now the heat is increased towards the equator. Due to that, what happens? Again, this low pressure belt is shifted towards the equator. And due to that, now after the September, now the wind is flowing from Indian continent towards the sea. Now, due to that, again the precipitation takes place, rainfall takes place. Okay, that is known as a retreating monsoon. Okay, retreating monsoon starts from October and that is for next 4 months. So this is about the types of monsoons. So first is southeast monsoon. So it reaches to the coastal area of India in southwest direction, and its journey continues up to the Himalayan ranges. Okay, this is one branch, and other branch goes parallel to the eastern coast and it reaches to the eastern states, that is Meghalaya, Assam, Mizoram, etc. And then after that, after 4 months, again the returning journey starts. So this is how in India the monsoon takes place. So that is the role of trade wind in development of ITCZ, and that is the role of ITCZ in which results in the precipitation over the Indian continent. Now this is the map which shows the various normal dates of onset of southwest monsoon. Okay, southwest monsoon cha dates are. So here we can see on Kerala coast it is 1st of June. Okay, then near to what the name of the place, this point is in Karnataka. Okay, so on Karnataka coast it reaches to 5th of June, and in Maharashtra it reaches to the 7th of June. Okay, and likewise these dates are shown in this map. Okay, so this is one sketch which shows the normal dates. Normal dates means what? These are the generally every year on these dates the monsoon reaches to India. But due to various reasons, sometimes it may reach late, okay, or sometimes it may reach earlier. So that difference is shown. What are the normal dates of southwest monsoon and what are the actual dates? So this is the map. Now, due to this retreating monsoon, the rainfall takes place in Tamil Nadu. Okay, in Chennai, we always heard the news that in December months or in January month, there is a flood in Chennai. So in that eastern coast, generally the rainfall takes place due to this retreating monsoon. So based on this Indian monsoon, a short note is asked in the exam. Write note on Indian monsoon. Okay. So now I will change the slide and we will continue with the next point. So after this, the next point we are going to discuss is measurement of precipitation. Okay, up till now we have discussed So after this, now we are going to learn how to measure the precipitation, measurement of precipitation. As explained earlier, measurement of precipitation is done with help of one instrument, which is known as a rain gauge. And these rain gauges are available in two types. First is recording type, other is non-recording type. In recording type of rain gauges, there are again three varieties: weighing bucket type rain gauge, tipping bucket type rain gauge, and float type rain gauge. Whereas in non-recording type of rain gauges, there is a Siemens rain gauge and standard rain gauge. Now at first we will discuss non-recording type of rain gauge, and in that first is Siemens rain gauge. Okay, so on the screen you can observe one figure which shows the non-recording type rain gauge, and in that there is a first type Siemens rain gauge. This Siemens rain gauge is placed over a concrete block whose size is 60 centimeter by 60 centimeter by 60 centimeter. And at the center of this concrete block, so one depression is made to keep the cylindrical vessel. So cylindrical vessel is used in this rain gauge whose diameter is 127 mm, that is equal to 5 inches. And this cylindrical vessel is kept in position as we can see in this figure. So it is kept at some depth below the top of the block. And the bottom width of this cylindrical vessel is 210 mm. Okay. So in this cylindrical vessel, then receiving bottle is kept. So that receiving bottle may have a diameter from 75 to 100 mm. That is, its diameter may be 3 inches or 4 inches. And this receiving bottle is having capacity to receive a rainfall up to 100 mm. Okay, maybe 75 mm in case of 3 inches diameter bottle and 100 mm in 4 inches diameter bottle. So the maximum amount of precipitation which can be recorded is 100 mm in case of Siemens rain gauge. Now on this receiving bottle, a funnel is kept, and that funnel is provided. Okay, and diameter of this funnel is similar to the diameter of cylindrical vessel. So that entire quantity of rain which is catched by cylinder, that is collected in the funnel, and through funnel it reaches to the receiving bottle. So very simple mechanism is there for this Siemens rain gauge. And as this is a non-recording type of rain gauge, every day manually the rainfall is measured. Every day attendant comes at 8:30 am and he removes that funnel, then he removes the bottle, and using some measuring cylinder, a glass measuring cylinder is with him. So using that glass measuring cylinder, he measures what is the amount of rainfall in last 24 hours. So directly he records what is rainfall in last 24 hours in centimeter or millimeter depth of water. Okay, and that measurement cylinder is calibrated with reference to this formula. What is this formula? Rainfall in centimeter is equal to volume of water collected in centimeter cube. So in this receiving bottle, What is the volume? That is considered in centimeter cube divided by area of aperture of gauge in centimeter square. So if we divide this with area of aperture gauge means the opening at the top of this funnel. So that is the aperture gauge. So its area is equal to the area of this cylindrical vessel or area of this funnel with brass ring. Okay, so this is how, with help of Simon's rain gauge, the measurement is taken or rainfall is recorded. So now our time is over. So let us stop here. In the next lecture, we will continue with the next type of rain gauges. So please wait, I have to note down the attendance.